So what we're going to do today is mass ratio problems. So these are the most work out of any of the problems or any of the math problems we're going to do in our math of chemistry unit. They are 3 steps and they are incredibly common in a chemistry lab. If you're doing chemical reactions, you're going to have to be able to do these calculations all the time. These are pretty common. So the first step is always going to be a mole formula, because we can't measure moles directly. We can only measure grams. So if you measure out a certain amount of grams of reactant, you're going to need to know how many moles that is. Then we do a mole-mole ratio to figure out how many moles of what we want to make or what we could potentially expect to make. And then we do another mole formula once we make it to figure out, well, did we make that amount? And that actually leads to other calculations like percent yield and limiting reagents and all that, which we're not going to learn. They're a little bit too advanced for what we need. But let's start with these and we'll see how you do. So the first thing you have to understand is these equations, again, have to be balanced correctly. So to balance these, I'm going to just balance them outright because that's not what we're here to do today. So there's our balanced equations. Now, problem 1, it says how many grams of NH3, so that's my ultimate goal, that's step C, are produced by the reaction of 5.4 grams of hydrogen. Well, that's step 1. Or A, whatever you want to call it. So I know I have 5.4 grams of hydrogen, but I can't just do a ratio where I put 5.4 over 3 because that's a mole number, right? These things are in moles. And this is grams, and I can't do it. I can do it for liters of gases, but this isn't liters. So I'm going to have to figure out how many moles this is. So the first thing I do is going to be my mole formula. The GFM of H2 is 2. I have 5.4 grams. I have 2.7 moles of H2. So now, once I know that, I can do a mole-mole ratio problem. That's step 2. So it's 3H2 and I have 2.7, and we want, now they want grams of NH3, but I still can't get there. But I can figure out how many moles of NH3 I have by doing this. So now I cross multiply here and I solve for X, and I end up getting 1.8 and then my final calculation, now that I know I have moles of NH3, I go back to the mole formula. My GFM is going to be 17 because I'm dealing with NH3, whereas here it was 2 because I was dealing with H2. I am going to figure out how many grams I have knowing 1.8 moles. So you solve this problem and you end up getting 30.6 grams of NH3, which again, that's my final answer. Okay, but I had to do all that work. I had to convert my grams of H2 into moles, then do a ratio problem, then convert it back into grams, which is very, like I said, very common. We've got 3 more, 1 more for this equation and 1 more for the next one. So for the next one, it says how many grams of N2, that's what I want eventually, are needed to react completely with 4 grams of H2. So there's my first step. I knew my GFM of H2 is 2. That's an easy one. They gave me 4 grams, so 4 divided by 2 is 2 moles of H2. Now I can convert my 2 moles of H2, and then in the equation it's 3H2, so I would go 2 over 3, and I want nitrogen, so X over N, or X over 1, N2. Now I get point 0.67 moles of N2. Okay, last step. Now my N2 is going to be, or my GFM of N2 is going to be 28. I want to know how many grams, and I know I have 0.67 moles. Final answer. So the reason we're doing these problems before our mass mole problems, they're like the halfway in between mole and mass mole, or mass. The reason we're doing these first, they're more work, but it's the same 3 steps in the exact same order every single time. So I find that students have a much easier time with these than they do with our next set, which would be essentially, if I started you with moles, you'd be starting on step 2 and then finishing on step 3. And if I started you with mass and only asked for moles, then you'd be doing step 1 and finishing on step 2. So basically it depends on your starting material, what you're given, if you're given grams or moles, where you're going to end. So that gets a little bit harder. We'll do that in the next video, but let's finish these. So for this next one, how many grams of SO3, that's what I want eventually, is being produced using 48 grams of oxygen. So mole formula. The GFM of O2 is 32. They gave me 48. 1.5 moles of O2. Now I do my ratio. I will have O2. I want SO3. So I have 3 here, 2 here. I have 1.5. So I go 1.5 over 3 equals X over 2. So in this case, 3X equals 3. So we get 1 mole of SO3. The GFM of SO3 is, well, sorry, put it in the wrong spot. The GFM for SO3 is 80. I do want to see the formulas after the GFM. It makes it much easier for me to make sure you're doing it right, and also to figure out if you're doing what you're doing wrong, if you are doing anything wrong. I've got 1 mole, we get X. Final problem, or the final solution, is 80 grams of SO3. All right, last one. They want SO3 again, but in this case, they give you 100 grams of just sulfur, which is just S. So the GFM of sulfur is just S, which is 32. They give me 100 grams. I solve for moles. 3.125 moles of S. There's step 1. Then I do a ratio problem to go from S to SO3. S has a 2 in front of it. SO3 also has a 2 in front of it, so that makes the math easy. So I get 3.125 moles of SO3. And then the last step, mole formula again. And we end up with 250 grams of SO3. So that's how you do these problems. It's broken down, it's color coded. Hopefully this makes it a little bit easier. In the practice problems that we're going to do, you're going to get basically a bunch of these with a little less space, but once you know how to do them, it shouldn't be it shouldn't be too hard. I'm also going to ask you to identify the types of chemical reactions, because we did learn that already, so I'm going to bring that back and ask you to tell me what types of chemical reactions they are as well.